Okay, today we are continuing graphing parabolas. 2 days ago we graphed in standard form, yesterday in vertex form, and today in intercept form. You guys liked the vertex form because you could look at the equation and you could see where the vertex was very easily. You're going to like the intercept form too, I think, because you can look at the equation and guess what you can see very easily? You can see the intercept. Let's remind ourselves what an intercept is. Intercepts are the points on the parabola, on the graph, that cross the axis. In this case, we're going to be talking about the points that cross the x-axis, and that's going to come from, in our equation, this expression and this expression. These are going to be our two x-intercepts. So let's go ahead and get started with an example. Yesterday I gave you a handout, and this is the same problem from the handout. So right now just follow along and see if you can figure things out rather than trying to write things down. So we have our equation in intercept form, y equals a times x minus p times x minus q. If we look at an example with numbers, not just letters, we can dissect it down and come up with this a, p, and q. So a in this case is going to be negative 1. P, we have to be careful because the equation shows negative p, and here we're looking for positive p, not negative p. So we're actually going to flip the sign and make this a negative 1. Q, same thing. Over here it's a minus a q, and here we don't have a negative, we have a positive. And so we need to flip the sign to keep things straight. So once we have broken down the equation, then we can say once again, if a is positive, it opens up and has a minimum, and if a is negative, it opens down and has a maximum. So in this case, a is negative, which means that it opens down and has a maximum. Sorry, it's a little crazy with this pin here. So we open down like that, which means that this top point will be the maximum. Okay, our next step gets us to the actual intercepts. The x-intercepts are just going to be our p and q, are just going to be negative 1 and 5. So our x-intercepts, negative 1 and 5. So if we go to our graph, negative 1 and 5, x-intercepts, that's on the x-axis, negative 1, and that's our origin, so 1, 2, 3, 4, 5. Oops. There's our point there. To be honest, guys, I never worry about the p's and q's. This is how I think about it. I say, okay, if it's the intercept form, it has to be on the x-axis. In order to be on the x-axis, our y value has to be at 0. And so what can I do to this equation to get the y equal to 0? Well, either this expression or this expression is going to have to become 0. And if I make this negative 1 plus 1, then I have a 0, which makes the y 0. Or in this case, if I have a positive 5 minus 5, that becomes 0. So I don't worry about the p's and q's. I just say, how do I make these expressions 0? And so that would be our negative 1 and our positive 5. Those are the x-intercepts. If you look at these, you'll notice that they seem to mirror each other. Yes, mirror. They reflect each other. So that means our axis of symmetry is going to be right in the middle. So if you want to have an equation for how to do this, our axis of symmetry is going to be just the sum of the intercepts divided by 2, halfway between. So if we look at step 4 here, we're going to have the axis of symmetry is going to be negative 1 plus 5 divided by 2, which is just 4 over 2, which is 2. So if we go back here, we said that our axis of symmetry was 2. So I'm doing this without a ruler, freehand. It's going to be ugly. Here's our axis of symmetry. It's supposed to be along the 2 here. And what you should remember is that the axis of symmetry, the vertex, is found on the axis of symmetry. And so we've got to figure out where the vertex is. And the way we're going to do that is just like we did it with the previous equations. We're going to take our axis of symmetry value x and plug it in and solve for y. So here's our equation that we're using. Y equals, we're using our axis of symmetry value x. Y equals negative, x is 2 plus 1, 2 minus 5, which is going to be, let's do it down here, negative 3, and this will be negative 3. Well, negative times a negative gives you a positive, and 3 times 3 gives you 9. So when x equals 2, y is 9. So our spot here should be it. When x equals 2, on our axis of symmetry, y is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. At the very top of our graph here is our vertex, and that's going to be our maximum here. So we need one more point to fill out our graph. If it's not already been used, I tend to use x equals 0 because it just works out for me. X equals 0, y will be, well, everywhere there's an x, you make it a 0. So that's going to be 1 and negative 5. Negative times negative gives you a positive. 1 times 5 gives you 5. So when x is 0, y is 5. So when x is 0, y is 1, 2, 3, 4, 5. We make our point there. Then what do? We have to reflect it across the axis of symmetry. So this is 1, 2 to the left, so we have to go 1, 2 to the right. Given how badly my axis of symmetry went, I can't wait to see the parabola here. Let's see. You're supposed to connect with a smooth curve, and I'm guessing that on regular paper with a regular pencil, your curve will be better than mine here. So here's our, whoops, smooth curve, smoothish curve going down there, and there's our parabola. So let's try another example here. So go ahead and try y equals x minus 3, x minus 7. Pause this video and turn it back on when you're ready for the answer. Okay, so here we go. If we identify the parts, break down our equation, we have a, in this case, is just 1. P is going to be, we've got to flip the sign because it's positive. P is going to be 3. And Q, flipping the sign here, is going to be 7. Our parabola, A is 1, is going to open up, and it's going to have a minimum value. So we look at our 3 and 7. Like I said, I just look at the equation and say, how can I make this 0? This would have to be 3, and that would have to be 7. So our x-intercepts are going to be x equals 1, 2, 3, and x equals 7, 4, 5, 6, 7. Halfway between these two is the axis of symmetry, so we're going to say x is 3 plus 7 divided by 2. 10 divided by 2 is 5. So 1, 2, 3, 4, 5. Okay, here's another beautiful axis of symmetry. Then we've got to find where's our vertex. Where's our vertex on this thing? Well, we plug in our x value because we know that the vertex has to be on this axis of symmetry up into our equation up here. So we say y equals 5, because x is 5, minus 3, and 5 minus 7. So that's 2 times negative 2. So that's negative 4. So on the axis of symmetry, y is going to be negative 4. So here we go. 1, 2, 3, 4. Then we just need to fill in another point and get our parabola. So what should we choose? Should we choose, we could choose the 0 point, but that might put us off the graph here. So let's actually choose one, maybe this one. So this was 5, so that's 4, x equals 4. But you can choose whatever point you want. So I'm going to say when x equals 4, y equals 4 minus 3, and 4 minus 7, that's 1, and negative 3. So when x is 4, y is negative 3. X is 4, y is negative 1, 2, 3. We've got to reflect that across the axis of symmetry, so this is 1 unit away, so 1 unit the other direction. And then we connect with our smooth curve. And voila, you've got it. Good luck on your homework.